Okay, in this video I'm going to go over a couple rates of change problems. So the first problem says if h at t is equal to this equation, which represents the height of a rocket fired in the air, where h is measured in meters and t in seconds, determine the average velocity over the first 3 seconds. So the key to this question is to know that the average velocity, or velocity, just means is the rate of change of position over time. So velocity is equal to the change in h over the change in t. If you were to graph the position function, then the velocity would just be represented by the slope of the secant or the tangent, depending whether if it was average or instantaneous. So in this case, we're looking at the average velocity. Anytime you want the average velocity, you need an interval over which you're going to be calculating this average velocity. So we need an interval of time. So the question said over the first 3 seconds. So the first 3 seconds would start at 0 and then go to 3 seconds. So from 0 to 3 seconds, what's the rate of change? So it's really just a slope calculation. So we want the height at 3 seconds minus the height at 0 seconds, because we're going between 0 and 3, all divided by the change in time, which would be between 3 and 0 seconds, so 3 minus 0. And so this is basically just a slope calculation, and you're going to work that out. So h at 3 means sub in 3 to the equation, so that's minus 4.9 times 3 squared plus 25 times 3 plus 2. So that was the equation. That's this equation up here, minus h at 0. So it's minus 4.9 times 0 squared plus 25 times 0 plus 2, all over 3 minus 0, which is just 3. So you're going to work out what these are. So it's a big calculation. Just put in your calculator, work it out. So for this first bracket, you're going to get the height of 32.9. So that's the height at 3 seconds. So it means it's at 32.9 meters. The height at 0 seconds, so its initial height. Work out this number, so these would both be 0, and you have plus 2, so it's 2, all divided by 3. Or 3 seconds. Then work this out, and you get 10.3 meters per second. So that means the rocket is sort of rising in the air at an average velocity of 10 meters per second. So therefore, the average velocity over the first 3 seconds is 10.3 meters per second. So this was an average velocity question. Okay, so we'll contrast that with this velocity question. So this is a second example. It says, if an object has a position function of s at t, and this is the equation which gives us the position of this object, where t is measured in seconds and s is measured in meters, determine the velocity at 2 seconds. So here we're still doing velocity. It's not height, it's position, but again, velocity is equal to the change in position now instead of height over the change in time. But this is not an average question, it's an instantaneous velocity question, because we're talking about it at a specific time and not over an interval. So here we want the velocity at t equals to. So not over an interval, but at a specific time. So when you're looking for an instantaneous velocity, you're looking for the slope of the tangent, which would be equal to, we're going to have to use that limit definition we developed the previous lesson for the slope of a tangent. So in this case, it's going to be the limit as h goes to 0 of, now in our previous case we used f at h plus t, but in this case it's going to be s because we're using the function s instead of f. So it's the position h plus the value you're finding the slope of the tangent, or in this case the velocity at. So it would be h plus 2 minus s at that point, so in this case 2, all divided by h. Okay, so now we're going to sort of plug this into the formula, into the equation, and evaluate the limit. So s at h plus 2, so that's going to be h plus 2, so it's 5 times h plus 2 squared, negative 5, minus 5 times h plus 2 plus 180 minus s at 2. So that would be minus 5 times 2 squared minus 5 times 2 plus 180, all divided by h. So now in order to evaluate this limit, you're going to have to expand and simplify this numerator. So let's do that. So I'm going to skip some steps here, but h plus 2 squared, you get h squared times negative 5, so you'd have minus 5h squared. Then the middle term from h plus 2 squared would be 4h times minus 5, so you'd have minus 20h, 4 times 5 is 20. And then 2 squared, you'd have 4 times minus 5, so you'd have minus 20. Expanding this, you get minus 5h minus 10 plus 180. So that's the first kind of big bracket. Now you need to expand this. So you have 2 squared is 4 times minus 5 is minus 20, but you have to distribute the negative sign, so you have plus 20. And here you have minus 5 times 2, so that's minus 10. Distribute the negative, so you have plus 10. And then the negative gets multiplied by minus 1, or by 180 to give you minus 180. All divided by h. And now, kind of an interesting thing, which we saw happens every time, is these constants, minus 180, positive 180, plus 20, minus 20, minus 10, plus 10. So they all cancel out, and all we're left with is terms with h. So the limit as h goes to 0, collecting like terms, you'd have minus 5h squared, and then minus 20h and minus 5h, so you'd have minus 25h, all divided by h. Now you can simplify this in a couple different ways, but easiest to see is just take a common factor on the numerator. So you have, I'm just going to common factor the variable part, the h. I know a 5 would also factor, but it's easy. It's not necessary to do. All over h, and the reason I only factor the h is because I'm only worried about that dividing out with the bottom, with the denominator. So we basically have eliminated the denominator. So we have the limit as h goes to 0 of minus 5h times negative 25. So now that it's just the limit of a polynomial, so you can do direct substitution. So this would become minus 5 times 0. So direct substitution, you just substitute the limiting value into the polynomial. Minus 25, and this is just minus 25. So that is the rate of change. That's the velocity at 2 seconds, the instantaneous rate of change. The velocity at 2 seconds. So therefore, the velocity at 2 seconds at t equals 2 is 25 meters per second.